So in the previous video we talked about the parents. We studied and talked about the parents from the mathematical perspective, but in this video we'll talk about the statistical, how to interpret the variance statistically. It is very important. In the statistics, finding the values, calculating the values one is not enough. We need to be able to interpret the result. So in this video we'll try to calculate the variance and try to interpret the values and find some conclusions. So let us suppose that we have the 5 dogs A, B, C, D. Suppose it denotes the 5 dogs, and these are the heights of the dogs in the millimeter. Now we need to calculate the variance. First, to calculate the variance, we need to find the mean of the height. Mean of the height is calculated here, and then we need to do more, subtract the mean from all this height, from this x values, from this height, and square them and find the summation of all these values, and we obtain the values, this value. Now the variance is calculated using this formula, like we find the summation of x minus mean square. We find the value this way, put the value here, and the number of n, there is only 5 dogs, so we put the n here, and this is the result of the variance. Now the result of the variance is a little bit big, so it will be little bit harder to interpret. So to make it easier, we can use the standard deviation. This standard deviation, when you remove the square from the variance, it will become the standard deviation. As you know, it is the basic mathematics idea. Like when you remove the square, you need to put the square root in the right hand side of the square root. This is the very basic mathematics. And we obtain the standard deviation 147. Now we have obtained the standard deviation, but we don't know what this value means. We have no idea. We have only calculated, but what this value implies, we don't know. Now we will try to interpret this value 100. What does this 147? I mean, what does this standard deviation implies? Now we will interpret the standard deviation with the help of this normal distribution curve. And this is the mean value, like this is the mean value, this is the mean value, and then all this region shaded with the red, with this red dot is first standard deviation. First standard deviation means x1 plus mean is the first standard deviation. This is the first standard deviation from year to year, first standard deviation, and from year to year. From year to year is the first standard deviation from x1 minus mean. From this region to this region, from year to year is the first standard deviation. So all this region with this red marked is the first standard deviation, and then this region from year to year is the second standard deviation. This is this dotted line. This is this second standard deviation. Now, how to interpret the result? All the values that lies within this first standard deviation from year to year in this region, is considered the normal values. They are very normal values because they lies very close to the mean values. They lies very close to the mean values. But the values that lies in this region, in the second standard deviation, are a little bit far from the mean. So they are maybe they are a little bit abnormal values. So now let's interpret the mean, standard deviation, and the variance. Now we are given the height of the dogs like this. Then the height of the dogs be BDE lies in this region in the first standard deviation between this. If you look at the value, like value of the B is 470. 470 lies in this region between 394 to 541. This is the first standard deviation. And then value of D is 430, and this also lies in between these two values. So this is so D value, so the D is also in the first standard deviation. Similarly, E is also in the first standard deviation, and the value of A is 600 millimeter. 600 lies in between 541 to 591 in this region, lies in this region. So the B is in this second standard deviation, is the positive second standard deviation. And the height of C, height of the C is 170 millimeter. 170 millimeter lies between 100 to 447. That is in the negative second standard deviation. This is also the second standard deviation, but it is, since it is in the negative side of the mean, so we call it the negative standard deviation. And since this is in this region is in the positive side of the mean value, we call it the positive standard deviation. But in simple term, both are called the second standard deviation. Now, since the BDE, since the dog height of the dog BDE lies in the first standard deviation, the height of the dogs are considered the normal heights. They are the very normal heights in the first standard, since they lies in the first standard deviation. And the height of the dog A lies in the positive standard deviation, that is a little bit far from the, since it lies in the positive deviation, that is, since it lies in the positive positive second standard deviation, whose value is bigger than the mean. So A is considered the abnormal height. Let's say it is larger height. This is the dog. A is the dog with the larger height, and the C lies in the negative second standard deviation, that is, whose value is the smaller than the mean value. And since it lies in the second standard deviation, it is C is the short. C is the dog with the short height. So our conclusion is that height of the dog BD is a normal height. Height of the dog A is larger, is the dog with the larger height, and this is the dog with the smaller height.